and welcome to day 2 of naming and formula writing. We are going to be doing binary ionic compounds with transition metals, and then next video you will go over ternary ionic, which means you're using things called polyatomic ions. So we're going to start by little review. Okay, so up here you learned, last class you learned how to do binary ionic just with regular metals where you know what their charge is. So you should know that sodium is in group 1, so it has a charge of +1. Fluorine is in group 17, which means it has a charge of -1, meaning we just need one of each to cancel out, so we just have 1. Here, calcium has a charge of +2, whereas bromine has a charge of -1. So we would need 2 bromines to cancel out that +2 charge to get them to equal 0. So today we're going to be doing this with metals that don't always have the same charge, or we don't know what charge it is. So looking here, this is iron 3 oxide. This, in parentheses, this is the Roman numeral for 3. Now, this 3 is not telling us that we're going to have 3 irons. No, it is telling us that the charge of this iron is +3. The charge of our oxide stays the same, it's still -2, so the ions that we have are iron with a charge of +3 and oxygen with a charge of -2. Now we need to make these charges cancel, so they need to add up and equal 0. So if we do that, we have +3 minus 2, okay? That equals 1. Well, 1 isn't 0, I need to get that less, so I'll add another -2. That equals -1 now. So I need to add, I can only add a +3 and a -2, so I add a +3, that gives me +2. -2 gives me 0. So I've used +3 twice and -2 3 times. So my -2 is -2. So I used oxygen 3 times, so it's going to be O3. Whereas my iron is +3, I used that twice. So that means I'm going to have 2 irons. So it would be Fe2O3. Now, if you don't like the math, that's okay. There's another way to do it. So here we have, the next one is tin 4 chloride. So tin has a charge of +4 and chlorine has a charge of -1. So if we were to write this again, what we could do is use what's called the crisscross method. So the number for the charge of this guy is going to come down and be the subscript for chlorine. The charge of chlorine is going to crisscross down and become the subscript for tin. Now, we don't write 1s, so whenever we do that, we would end up with SN1, but we don't write it, Cl4. So SnCl4. So let's do that here with lead 4 oxide. So lead is Pb. This is Roman numeral 4, so that means that this lead has a charge of +4. Oxide is oxygen, and oxygen always has a charge of -2. Now, if we were to do it the math way, we could do 4 minus 2, and then we would need another -2, and that would equal 0. So we would end up with 1 Pb and 2 oxygens. If we wanted to do it the crisscross method, we would have Pb +4, O -2, and we crisscross. But if we do that, we end up with Pb2O4. That isn't quite correct because we only need 1 Pb and 2 oxygens, not 2 Pbs and 4 oxygens. So if you choose to do the crisscross method, that's okay, but then you have to ask yourself, at the end, can I simplify this? And the answer is yes, I can take these 2 and divide them both by 2. And if I divide both of them by 2, I end up with PbO2. And that's the correct answer. So you can, if you did it the math way, you would have come up with PbO2 the first time. If you chose to do crisscross, you would have come up with Pb2O4. Then you would have had to ask yourself, can I simplify? The answer would have been yes. So you simplify to make it PbO2, and that's your final answer. All right, so I want you to try bismuth 3-sulfide on your own. So pause the video and then come back and we'll go through it together. All right, so bismuth 3-sulfide, bismuth has a charge of +3. Sulfide is sulfur, and it always has a charge of -2. So we can do it the math or the crisscross. If we do math, okay, well, we can recognize that that's not going to equal 0. We're going to have +1, so I need to add a -2. Well, 3 minus 4 is not 0, so I would need to add another 3. That's 6 minus 4. That's still not 0, so I add another -2. That's 6 minus 6. That equals 0. So we can ask ourselves, okay, how many times did I use the +3? The +3 is my bismuth. I used the bismuth twice, so I would have Bi2. Next is my sulfur. It has the charge of -2. How many times did I use it? 1, 2, 3. So I used the sulfur 3 times, Bi2S3. Now y'all are going to have plenty of practice to try this. I will say this is definitely the hardest part of this unit, is trying to find the charge of your, it's making sure that you can crisscross it. Doing it with transition metals is definitely the hardest part for this, okay? However, now we have to be able to name it, all right? So whenever we name it, we're always going to, just like before, name the metal. Okay, but then we're going to place the charge of that metal in using Roman numerals in parentheses afterwards. So that's this here. So lead 4 oxide, we're placing the charge of the lead in Roman numeral with Roman numerals in parentheses right afterwards. And then we're going to name the nonmetal using the IDE ending, so changing chlorine to chloride, oxygen to oxide. All right, so looking at it here, so this here is where things can get especially a little tricky. So we have to be able to find the charge of the lead, okay? We don't know what it is, but we know that lead is not always +4. It's not always +2. It could be something, so we have to figure it out. The way that I like to do it is you need to know what the charge is of your anion, your negative charge. Well, chlorine has -1. There are 2 of them. So I'm going to multiply that by 2. So my total negative charge is -2. Okay, so then I'm going to look at how many leads I have. I have 1 lead. So that means the charge of this 1 lead has to be the opposite of -2. So I'm going to take my charge here and divide it by how many of this guy I have. I have 1. Okay, so that means it's going to be 2. Now we switch it to be positive because it has to be the opposite of this guy to cancel it out. So we're going to end up with lead 2 chloride. Looking at the next one, it's Cu2S. We know, but we don't know what the charge for copper is. Copper is a transition metal, so we have no clue. So what we're going to do is look at the charge of our sulfur, because we know that never changes. The charge of our sulfur is -2. How many sulfurs do I have? Well, I've got 1 sulfur. So that means my total negative charge is -2. So now I'm going to look at my positive, whatever I'm trying to find. It's copper. I have 2 coppers. So that means I'm going to take this -2 and divide it by 2 because I've got 2 coppers. And when I do that, that's going to tell me 1. So that means the charge of each copper is 1. And that makes sense because the total positive charge, if we use 2 plus 1s, that gets us plus 2. That cancels out the negative 2 here. Okay, so let's do another one. This is SnO2. We've got O. That's our nonmetal. The charge of oxygen is always negative 2. Okay, so now I've got negative 2, and how many do I have? I have 2 oxygen, so I'm going to multiply it by 2. That gets me a total of negative 4. Now I'm going to divide by how many of these guys I have. I just have 1. So that means the charge of this tin has to be positive 4 to cancel out the negative 4. Sn, that is 10. And we figured out that the charge of tin is 4, so in Roman numerals, I'm going to put the Roman numeral 4. And then oxygen becomes oxide. All right. Now, I want you to see if you can do the COF3 all on your own. So pause the video and then come back and we'll check it. Okay, so this fluorine here, this is F. That's our nonmetal. It's in group 17. It always has a charge of negative 1. There are 3 of them, so negative 1 times 3 means I have a total of a negative 3 charge. CO, there's only 1 of them, so if I divide by 1, that means for this CO to cancel out the negative 3, it has to be positive 3, because there's only 1 of them. CO, that's cobalt. We figured out the charge is 3, so in parentheses, I'll put Roman numeral for 3. And then F is fluorine. Instead of writing fluorine, we have to write fluoride. All right, so if you have any questions, please come ask us. I will not be doing these practice problems. You are welcome to check with your teacher to look at the key as long as you've attempted them. After this video, go and watch the next one to finish out your day 2 notes. It will be over ternary compounds using polyatomic ions. All right, see y'all later.